All right, so today we're going to review this idea of slope and graphing linear equations. Now, some people might be thinking, well, what does graphing have to do with what we've been talking about? Well, we've been dealing for this entire unit on equations or linear equations. But now we're just taking it to the next level and graphing equations with two variables, which means it will be in two dimensions. Hence, your graph paper with a two-dimensional coordinate plane there. Okay? All right, so rate of change of a line is its slope. And we've been focusing on this literal equation idea with solving equations that look like this. In other words, equations that are in slope-intercept form. It's called slope-intercept form because of the fact that we have a slope and a y-intercept. So when we are finding the slope of a line, and part of this is in your notes and part of it is not, so you'll have to figure out where you need to add stuff. Slope of a line sometimes is referred to as the vertical change over the horizontal change, or sometimes it's given as the rise over the run. The rise over the run. Rise means going up or down. Run means going left or right. So if we take a look at what we have in this graph here, and I go from one point to another, as you can see that I just decided to start at that point right there. It doesn't really matter what point you start at. But if I want to start at this point and go to the next point up, I have to rise 2. And when you go up, that's positive movement. Downward direction, that's negative movement. From there, after I rise 2, I'm going to run 1 to the right. So when you go to the right, think about a number line. Going to the right is positive movement. However, going to the left is negative movement. And why is that? Because when you go to the right on a number line, the numbers get bigger. When you go to the left on a number line, the numbers get smaller. So our rise is rise positive 2, run positive 1, and if we simplify that, the slope is 2. Now, we typically use the letter M, as you can see right there, for slope. So we don't have to write slope every single time. We can use the letter M. And one thing that you should notice is that slope is also the number that's attached to the variable x here. That's where that mx plus b comes from. And so what I just showed you here, I went a little too far, is it doesn't really matter what point you start at or what point that you end at. Like for right now, I'm going to start at that same point, but I'm going to go in the downward direction. So if I did that, I would go to the left 2 and down 4. But if you do the rise over run, that would give you negative 4 over negative 2. And negative 4 over negative 2 simplifies to 2. So it doesn't really matter where you start or where you finish. So once again, the slope is always the number attached to the variable x if it's in slope-intercept form. Now, this other number, this minus 3 or negative 3, depending on how you want to say that, is what's referred to as the y-intercept. It's always where a graph crosses the y-axis. And those two pieces are very important when we're graphing. So, slope-intercept form gives us the slope, and it gives us the y-intercept. But let's do a little focus on finding the slope right now. So here we have a graph. We have 2 points that are plotted. On your number 1 in your notes, please find the slope. That should take about 2 seconds, maybe 3. Remember, slope is referred to sometimes as the rise over the run. Anybody have it? Yes?
1 over 3.
1 over 3. So, we have to count how many we are rising. So, I don't count until I move. There is a rise of positive 1. So my slope is a rise of positive 1, and then I count how many I run. 1, 2, 3, and since I went to the right, that is a positive 3. So I have positive 1 over positive 3, which is 1/3. So the slope is 1/3. Any questions about that? Rise 1, run 3. All right. Everybody try this one. Just make sure you write m equals whatever it happens to be. What's the slope in this one? 3 over 2. We are rising 3. Remember, you don't start counting until you move. 1, 2, 3. I went up 3, and then I went to the right 2. You don't count until you move. And that is 3/2 for the slope. Leave it improper. How about this one? What's different about this line? What's different about this line? Lauren? It doesn't have points. Well, it does have points. They're just not plotted, right? There aren't big dots there for you. So when you have a situation like this, you have to find where those perfect ordered pairs are. Where's one perfect ordered pair on this graph? Yes? 2 and 0. I don't know what 2 and 0 means. Do you mean 2 comma 0? Okay. 2 comma 0 is 1. Where's another one? Yes?
Negative 2 comma 1.
Negative 2 comma 1. So sometimes you have to sort of find them. Okay? Regardless, find the slope, please. Well, that's a good question. The question was, well, if it's negative, do you want me to put it on the bottom? Usually when we have a negative fraction, which is what slope gives us in many cases, the negative is just off to the side. The reality is, for example, negative 2 over 3 is the same thing as 2 over negative 3, which is also the same thing as negative 2/3. That's something that you should have dealt with last year. Okay? So, what's the slope? Sam? What's that? It's negative 1/4. We have to rise 1 and run 4 to the left if you went up and over to the left, or if you went in the downward position, that's negative 1, and run 4 to the right, that's positive 4. But regardless, it should be negative 1/4. It doesn't matter whether you put it on top, on the bottom, or off to the side, they all represent the same negative 1/4. Okay, try that one, please. Alicia, what's the slope? It should be negative 2. We're going to either go up 4 and right 2, or there's all kinds of things you could do. In my case, I went down 4, right 2, but regardless, you should end up, after you simplify, with a slope of negative 2. All right, so what if you don't have a graph? Well, there is an algebraic way of finding the slope, and it's basically utilizing this idea of rise over run. So, if I say that the lower ordered pair is ordered pair 1 and the upper ordered pair is ordered pair 2, and I use a little bit of algebra, I can quickly figure out a formula for the slope. And this is something that you should have talked about last year. Because when you're doing the rise, you're really finding the difference of the y numbers. And when you're doing the run, you're really finding the difference of the two x numbers. So, is this written down in your notes? Yeah. Can you please put a rectangle around it? Because we're going to refer to that many times this year. So, y and then little 2, we say that as y sub 2. So it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What that really means is this. So listen carefully. It really means the second y number minus the first y number. So in this case, it would be 2 minus negative 3. And on the bottom, we're finding the difference of the x's. So second x minus the first x. So in the case of these two, 1 minus negative 2. And in this case, we would get a slope of 5/3. All right, so let's do a little practice of that using the algebraic method or the slope formula. Everybody find the slope for number 5. So here's the first thing that typically happens every single year when we shift to this slope formula, if you want to think of it that way. Some people, when they're not thinking, they do the difference of the x's on top and the difference of the y's on the bottom. If you want to make a quick little check, the slope is the rise over the run. Rise is dealing with a vertical line or the y-axis. That's one little tip to you, that the y, difference of the y's has to be on top. And as I walk around right now, sure enough, I see a couple of people, they did the difference of the x's on top because they're not paying attention to what they're doing. Using the slope formula, that is the first order pair, negative 1, 3. 4, 7 is the second order pair. You could take them in reverse order if you wanted to, but either way, it should be 7 minus 3 on top, and on the bottom, 4 minus negative 1. And the slope should be 4/5. It's the difference of the y's on top because that is the rise, and the difference of the x's on the bottom because that is the run. Rise over run. Rise is that, run comes from that. All right, everybody try number 6, please. All right, Aaron, what did you come up with? Negative 2/7. Using the slope formula, the second y is 7, the first y is 5, so that's 7 minus 5 over. Second x is negative 1 minus the first x, which is 6. When we simplify that, we end up with 2 over negative 7, which is negative 2/7. All right, let's do one more of those. Hold on a second. There we go. We have 1 minus 7 over 4 minus negative 8. Or this time what I did is I did something a little different. I pretended like this was the second order pair and that was the first one, just to prove it doesn't matter which order pair you take first. You just have to be consistent. So if you call negative 8, 7 your second order pair, it needs to be second order pair on both of them. So in this respect, I'm going to have 7 minus 1 over negative 8 minus 4, which is 6 over negative 12, which simplifies to negative 1/2. So regardless, you should end up with negative 1/2. So we have 2 more to do, but both of these have something in common. Could I get everybody to quickly do number 8? Anybody have it? Yes.
0.
It is 0. Using the slope formula, we end up with 0 over what? Over 3, good. And 0 over 3 is 0 because that's 0 divided by 3, and that is 0. If you left it as 0 over 3, that's like having a fraction that's not simplified. 0 over 3 is 0. However, what about number 9? Try number 9, please. So in this one, we have negative 1 minus 2 over negative 3 minus negative 3, which of course gives us negative 3 over 0. And every year when we run into this the first time, there are a few people say, that's easy, that's 0. And I say, no, it's not. Let me show you a little example. What's 6 over 2? All right, it is 3. If we think of that going backwards, we know that it works because 2 times 3 is equal to that number right there. Okay? We can use that same logic to deal with 0 over 3. 0 over 3 is 0 because 3 times 0 is 0. If you think that negative 3 over 0 is 0, then you're saying that 0 times 0 is negative 3. Obviously, that's not true. So then the next question might be this. Well, what could that be? What number could represent the answer to this? Yeah, exactly. There is not a number that you could put over here where if you multiply it by 0, you will get negative 3. And in mathematics, when that happens, we say that that is undefined. There is not an answer that will represent that. I hate using, some textbooks say it's no slope. I hate introducing that because some people think of no slope as 0. They aren't two different things. Or they are two different things. I prefer undefined anytime 0 is in the denominator. Okay? So, need to watch out for those two. And if we think about a graph, all I'm doing right now is I am plotting number 8 for us. We end up with a horizontal line. Any horizontal line has a slope of 0. If I have the other two, number 9 in other words, and I plot both of those ordered pairs, that ends up giving us a vertical line. Any vertical line has a slope that is undefined. And I don't know if this is in your notes, but you need to make sure you get this very clear. Horizontal lines have no slope as far as an incline or a decline. That means that the slope is 0. And a vertical line has a slope that is undefined. So to summarize it, I did put a little chart in your notes. Any line that goes uphill from left to right has a positive slope. Any line that goes downhill from left to right has a negative slope. Any line that is horizontal has a slope of 0, and any line that is vertical has a slope that is undefined. Okay? Any questions so far? Let's go to the back side. So we've already talked about this idea of slope-intercept form. The reason why y equals mx plus b is referred to as slope-intercept form is because that number that is attached to the x, or m in this case, is the slope. The number that's off to the side, the constant, or the b number, is the y-intercept. And any equation that is solved for y is in slope-intercept form, as long as we're dealing with a linear term of x. All right, so number 1 I will do for us, and then we'll state all the rest of them together. Number 1 has a slope of 3 and a y-intercept of 4. I believe this is where you're starting to fill things in. In number 2, what is the slope? What is it? 5. What number are you on?
Oh, ours is.
Oh, yours are numbered differently? Just find number 2, okay? Yeah, it's written a little different, in different order than mine. Okay, so my number 2. What is the slope?
-2.
-2. What's the y-intercept? All right, -1. My number 3. What's the slope?
5.
What's the y-intercept? 0. In my number 4, what is the slope? 5 over 8. Do you have different problems than me?
Just the last one.
Just the last one. Okay, another note issue here. In my number 4, the slope is 5/8. What's my number 4's y-intercept? Okay, and these are extremely important because they help us graph quickly. Now let's flip it. And you may need to look up here because, I don't know if there are any more note issues here. In my number 1, the equation of that line, since the slope is 2 and the y-intercept is -3, would be y equals 2x minus 3. In my number 2, what would the equation of that line be if that's the slope and the y-intercept? Yes?
Y equals 2/3 x plus 5.
Very good. In my number 3, what would the equation of that line be? Yes?
Y equals -3/7x plus 2.
Very good. In my number 4, what would the equation of that line be? Yes?
Y equals -2.
Excellent. You didn't say 0x. You don't need to say 0x because there isn't an x, or there isn't a slope. The slope is 0, so we don't need to put the x part of it. And then how about number 5? What would that be? Y equals -1/2 x. Very good. All right, so now let's shift over to the graph paper. And we're going to quickly graph y equals -2/3 x minus 1. In the equation y equals 2/3 x minus 1, obviously the slope is 2/3. And the y-intercept is -1. Those two pieces help us graph very quickly. So what we do is we plot the y-intercept. Remember, the y-axis is the vertical axis, so the y-intercept is crossing that axis. Since our y-intercept is right here at -1, we're going to plot our y-intercept. So right there is our y-intercept at -1 on the y-axis. From there, we're going to use the slope and this idea of rise over run to find 2 more ordered pairs. So since our slope is 2/3, from there we're going to rise 2 and run 1. Or excuse me, run 3, sorry. So rise 2 and run 3. So we'll put another dot right there. And you have a coordinate plane that is bigger than mine. And then from there I'm going to go and do another ordered pair by rising 2 and running 3. So that would be rise 2, run 3, and then take your ruler and make sure your line goes through the entire coordinate plane and make sure we have arrows at the end. So once again, we take our y-intercept, we plot it, we use our slope to rise 2 and run 3. Now I went ahead from this one, went up 2 and over 3 again, but you could go back to the original point and go down 2 and left 3 because a negative over a negative, or negative divided by a negative, is a positive. So you could have done a number of things. But I need you to have at least 3 ordered pairs on your graph. I did 5 up here. We don't always need that many. 3 is enough. Okay, any questions about the idea of graphing with slope and intercept? All right, everybody do this one right here. Y equals negative 1/2 x plus 4. Once again, in the previous problem, the slope was a positive number. The line went uphill from left to right. Any line that has a negative slope better be going downhill from left to right. So here's what you should have done. The slope is negative 1/2. The y-intercept is 4. We should have plotted our y-intercept right there at positive 4 on the y-axis. From there, you could either go up 1, left 2, or down 1, right 2. But why would you not go up and to the right? Why would you not do that? Yeah, one of the two, either the rise or the run, has to be negative. Not both of them negative or both of them positive. So then we plot the slope. I went down 1, right 2. You could have gone up 1, left 2. But you need to do that again, whatever you do. And I'm putting up a lot more ordered pairs than I actually need to. But then we need to make sure our line covers the entire coordinate plane. And we have arrows at the end of it. Okay? Any questions there? So our last thing for today, in your notes, you have 2 graphs. And you are to come up with the slope-intercept form of the equation that represents both of those lines. I want you to discuss them with your shoulder partner, and with your shoulder partner, come up with the slope-intercept form of the equation that works for both of those. I'll give you about a minute to a minute and a half. Go. All right, the graph on the left. What equation would represent, in slope-intercept form, which equation would represent that graph? Yes? Y equals 2x plus 3. So we're kind of working backwards here. In order to find the equation of that line, you need 2 pieces. The slope and the y-intercept. That's why the equations are referred to as slope-intercept form. So the y-intercept is obvious. I didn't put a dot on it, but it doesn't matter. It's crossing at positive 3. And the slope is rise 2, run 1. When we piece that together, it should be y equals 2x plus 3. How about the graph on the right? What would that be? Yes?
Y equals negative 1/3 x minus 4.
And I can tell the fact that it's going downhill from left to right, the slope has to be negative. I don't know what it is by just glancing at it, but I know it has to be negative. So the y-intercept is right here at negative 4. That's where the graph is crossing the y-axis. Right there at negative 4. And then the slope is, depending on which ordered pairs you use, it is negative 1/3. So when you put that together, the slope-intercept form of the equation of that graph is y equals negative 1/3 x minus 4. All right, we are finished.